Namaskaram everyone. Welcome back for the mathematics session. This is the 10th lesson in circles, and by now Sanjeev Kumar sir is all well known to you, is familiar to you. He has been teaching circles from the last 9 sessions. He has already dealt with equations of circles in various forms, equations of tangent, equation of chord of contact, how to find the point of contact of the tangents, how many number of tangents that we can draw in different cases. All the questions were detailed, all the concepts were detailed in detail discussed, and he has also solved many problems from the exercises as well. And today's topic is pole and polar related to a circle. What is called a pole and how a polar will help. Sanjeev sir is going to help us and make it more clear with examples as well as diagrams. Over to you, Sanjeev sir.
Thank you, madam. So good afternoon, children. So hope you have been following the classes and you have been working on the circles. Today we are going to discuss a very important aspect of the circles. It is the polar and the pole. So you call pole and polar, but actually we start with the polar and find out pole, right? So what exactly you have learned in your previous classes? Just recapitulate, right? If you take a point and you are going to draw a tangent to the circle, how many tangents are possible? The number of tangents from a point, right, to the circle, right? If the point is outside the circle, exterior point to the circle, you'll get always a pair of tangents. So it means that you get 2 tangents from that point. If the point is on the circle, you get only 1 tangent at that particular point. Okay, so through a point on circle, only 1 tangent is possible. And if the point is an interior point, then you cannot have any tangent. So when the point is inside the circle, no tangent is possible. So exterior, pair of tangents; interior, no tangents; point on circle, 1 tangent. We also discussed about the angle between the 2 tangents. Some relation was discussed. It was relation with the angle, radius, and length of the tangent. You had used the formula tan theta by 2 is equal to r divided by square root of s11. So theta by 2 is half the angle. If you just take the entire angle, it is theta. R is a radius and root s11 we are called as length of the tangent. Then we discussed about the chord of contact and what exactly is the equation of chord of contact. So equation of chord of contact was S1 is equal to 0. So remember what is S1 is equal to 0? It is xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0 if you take the circle as s is equal to 0. If you take the circle equation as x square plus y square is equal to r square, the equation of the chord of contact was xx1 plus yy1 minus r square. So let us go to the very important aspect of the circles, the pole and polar. So for that you take a circle which you call as s is equal to 0, right? And you take a point P on a plane, right? So the point P can be outside on the circle or inside. So for representation, we take the point as outside and start. Then we discuss about point on circle, then point inside circle. So let S is equal to be circle equation and P be any point in the plane other than the center of the circle. So the point, whatever you are going to take can be anywhere in the circle or on the circle, outside the circle, but it should not be at the center of the circle. Now, if at all you draw lines from the point, right, to the circle, right? Now, if you are able to draw a line and the line is meeting the circle at 2 points, one you called as Q and second you called as R. Now see here, you got a point here, you have taken a point here, and you're drawing a line. Now you see that this QR is a chord, right? So this line, whatever you have drawn, it is cutting the circle or touching the circle, cutting the circle at 2 points. One is Q and second is R. Now from this Q and R, if you are able to draw tangents, QA and QB, QA and RA, then what did you call earlier this QR? This is what is called as secant, and with respect to the point A, you are calling it as chord of contact. Yes, when you see from the point A, this is what is called as chord of contact, but you are actually observing from the point P. So if any line drawn through the P meets a circle at 2 points Q and R, then the point of intersection of tangents. So you got the two tangents intersecting one point. At what is that point? The point is A. Now, instead of this line, if you take another line, say you got line P, this is what is called QR. I have taken another line. That line is also cutting the circle at Q1, R1. I have taken another line, Q2, R2. Now, when you take QR line here, or P with the P traveling to the Q and R, you got two tangents. These two tangents are meeting at this point. Likewise, when you take the line as Q1, R1, right? So the tangents at Q1 and R1 are meeting at this point. Likewise, when you take the tangent at Q2, R2, it is meeting at this point. So when you take these 3 points, I have taken only 3 points. You can take as many points as you like, as many tangents, as many lines as possible, right? So they all lie on a common line. So that line is what is called as polar. So if a line drawn through the P meets a circle at 2 points Q and R, then the points of intersection of tangents. So the point of intersection of tangents, this is a point of intersection of tangent, this is a point of intersection of tangent, this is also a point of intersection of tangent. So they are all lying on a same line, and that line is what is called as polar of P. So let us try to understand this. Say I got a circle here, S is equal to 0. You have taken a point equal as P here. The line is cutting the circle at 2 points. One is Q and second is R. Now, instead of, if you take the tangents at Q and R, they meet at a point. You can see that they are meeting at a point. Now, again, you take another line. It is also a chord to the circle, secant to the circle. You can just see that this line, second line, is also meeting the circle at 2 points. One equal as Q1, second equal as R1. Now draw tangents at Q1 and R1. They meet at a point. Now you got 2 points. Likewise, you can take another line, we called as Q2, R2, and draw tangents. They meet at a point. Now you join the points of intersection of the tangents here, these points. So what you get is the polar of the point P. And from where you are starting from the point. You are actually starting from the point. This point is called as pole. So the point from where you are discussing is what is called as pole. So try to understand this definition very well, right? The point P is called as pole of the polar. Now let us discuss how to find the equation of polar for the circle. So if you take the point as Px1, y1 with respect to circle S is equal to 0, the equation of polar is again S1 is equal to 0. See, this was the equation which are used for equation of tangent, equation of chord, now also equation of polar. So it is very, very important. So equation S1 is equal to 0 is the equation of the polar also, right? Now let us see this. Now you got a point, line P cutting the circle at 2 points Q and R, and you're drawing tangents from Q and from R. They are meeting at a point you called as A here. So what you are called, like you can, like this, you can draw many number of chords and draw a line. That line is what is going to be the polar, and this point which you are starting with is what is called as pole. right? So let QR, which you have taken, the line segment QR, or you can say the secant, you can say that QR is a chord drawn through point P. So you're starting from the point P and drawing a chord. You can also call it as secant. Okay. Now, you got tangents at Q and R, tangents and Q and R meeting at a point A. So let the tangent at Q and R meet at a point A. The A coordinates of A, you are calling it as A alpha comma beta. Now this QR, which you have taken with respect to this point, you are calling it as chord of contact. Do you agree? So here, this line QR, the secant line QR, you can be called as chord of contact with respect to the point A comma A of alpha comma beta. So from this point P A alpha comma beta point of view, this QR is a chord, right? From this point of this QR is a line passing through the same point. So it is PQR are lying on same line, right? Now, so what is the equation of chord of contact? You have used the equation as S1 is equal to 0 if you take the point as X1, Y1. But the point is what here? Alpha and beta. So instead of X1, Y1, you have used alpha and beta. So what is the formula? S1 is equal to 0. X1 is nothing but alpha. Y1 is beta. G times X plus alpha, F times Y plus beta plus C is equal to 0. Right? So just don't confuse yourself. This is what is alpha beta. We are used alpha beta in place of X1 and Y1, right? Equation of chord of contact. Now, this equation of chord of contact, this line equation is given by the equation here. Now, this line is passing through the point Px1, Y1. Do you agree, children? See, on this line, you got this point also. So this means that this point should satisfy this equation. So it passes through the point Px1, Y1. So what is the meaning of it? You can replace X with X1 and Y with Y1. So what you get is X1 alpha plus Y1 beta plus G times X1 plus alpha plus F times Y1 plus beta plus C is equal to 0. Okay. Now, what you got is a condition here: X1 alpha, Y1 beta, G times X1 plus alpha, F times Y1 plus beta plus C is equal to 0. Now, if you take another chord from here, right? So they meet at another point, say alpha 1, beta 1. You take another line, it cuts a circle at Q2 or 2. They meet at a point, say A2, alpha 2, beta 2. So which is a variable here? This alpha and beta are variables. Okay. So you can replace this alpha and beta in general with a general variable X and Y. Why? Because these 2 points, this is what is one tangent, one point you got. Like this, you get another point here, another point here, or another point there, right? So you get points like this on a line. So you can replace alpha with X and beta with Y. So A alpha beta satisfies the equation S1 is equal to 0. So the equation of the polar of the point Px1, Y1 is S1 is equal to 0. What is S1 is equal to 0? X x1 plus y y1 plus G times X plus x1 plus F times Y plus y1 plus C is equal to 0. So what is the procedure you have followed here? First of all, you have taken the equation of chord of contact from the point alpha beta. You got an equation like this. Now this is passing through some point x1, y1, substitute the point x1, y1 there. In place of x, you put x1, in place of y, you put y1. Then what is it you have done is, you have changed this line. Instead of taking QR, you have taken another line, which is called as Q1, R1. Then again you get another point. So this point is a variable point. A alpha beta is a variable point. So in place of alpha and beta, you can replace with X and Y. So you get X1X, or you can simply write XX1. Then you get Y1Y or YY1. G times X1 plus X. So you can write as G times X plus X1. F times Y1 plus beta. Beta you can replace with Y here. So F times Y1 plus Y. or f times y plus y1, just exchange the places, then plus c is equal to 0. So have you understood this, children, here? So equation of polar is S1 is equal to 0. Now, if the point is an exterior point of the circle, so what do you mean by exterior point? The point is lying outside the circle. Now, what is the meaning of it? If the point is outside, so you see that the same situation we have taken earlier. So this what is the point which is outside here and it is cutting the circle. So you got two tangents, they are meeting at a point A. Now, if you take this point, this line, only one situation, only one point is there and you are able to draw a chord here, right? With respect to A, you are calling it as chord of contact. Now, because you don't have any other line here, you don't have any other line, right? So you can say this line as it is as equation of polar. So if P is an exterior point of the circle, then the chord of contact will be the polar of P. So there is no difference between the polar chord of contact and polar when the point is lying outside the circle. Now, what is going to happen if the point T is lying on the circle? Now, see here, this point P is on the circle. Do you observe here? The point P is on the circle, right? Now, what is that you do is through P, you draw a chord. This is what is PQ. Then draw tangents. So this one tangent is also one tangent. So these two tangents are meeting at this point. Now keep this point as it is because the point is fixed. Now you draw another chord keeping this P fixed. What is going to happen? You get another chord. So you get the tangent here, somewhere here, or if you take this point Q here, you get tangent. So because this point P is fixed, this tangent is also fixed. Okay, so only thing is this tangent is going to change according to the point Q. So when you move this point Q here, this tangent line also moves, but this line is always fixed. Okay, so you join all this, you get set of points. There's a set of points, nothing but polar of P. And this point P is a pole. So whenever you got the point lying on the circle, the polar of P coincides with the tangent at P. There is no difference between the polar and tangent when the point is lying on the circle. Now, if the point P lies inside the circle, now earlier when you have taken the point lying in the side inside the circle, you never had a tangent, you never had a chord of contact. Now observe. What is it you here? Got point P is on the circle, inside the circle or interior of circle. Now through this point P, you are drawing a chord. What is the chord here? QR. You can see the QR here. Now from this QR, you draw a tangent. Q tangent, second tangent here. They are meeting at this point. Observe here. So you got QR is a chord and the QR is passing through some point P because that is a focused point, the point P for which you are going to find the polar. Like again, you see that same P, for the same P here, you got another chord here. We call it again as Q1, R1. From Q1, draw tangent. From R1, draw tangent. They meet at a point. Likewise, you take another point, Q2, R2. Draw tangents, they meet at a point. All these points lie on a line, right? So the line where all these points are lying, that is what is called as a polar. Now see the first figure and the last figure. Now where is the point? It is outside. What is a polar doing? It is cutting the circle. The point is outside, the chord is cutting the circle. If the point is on the circle, the polar is touching the circle. And if the point is inside the circle, where is a polar? You observe it as outside the circle. So this dotted line is a polar here. Is it inside the circle? Nowhere touching the circle here. So when the point lies inside the circle, the polar is outside. The point is outside the circle, the polar is inside the circle. So simple observation you can make here. Okay. So third case, you observe it is outside the circle. So the point P lies inside the circle, then the polar of P does not intersect the circle and it is outside the circle. There is no intersection between the circle and the line. So let us take another point here. If P is a center of the circle, S is equal to 0. Now, what is going to happen if the point is the center of the circle? So just observe the previous figure. Say, for example, you got the point P here. Now, what you are going to do? You are going to draw a chord, right, through this center. So if at all you draw a chord, one second. Okay, so just try to draw here. So I got yeah. So okay, that stool has not come. Okay, fine. So I try to draw a line passing through the center. Now imagine the point is here. Now what is it to do actually here? You're going to draw tangents. So one tangent E will be like this, and second tangent will be like this. Will the tangents meet? So definitely there is no meeting point for the tangent. So once the circle, inside the circle, the point is exactly in the center, then you will not have any point of meeting of tangents. So that means that there is no polar if the point which you are taking is at the center of the circle. So if P is center of the circle, S is equal to 0, then the polar of P does not exist. The polar of P minus G minus F, what is this? This is what is center of circle, does not exist. Okay, so let us try to recapitulate what exactly you have taken in the tangent, chord of contact, and polar here. When you take the point as interior of the circle, when the point is inside the circle, the tangent does not exist. When you take the point in the interior of circle, chord of contact also does not exist. And when you take the point inside the circle, the polar is again S1 is equal to 0. So see the difference. The tangent is not there, chord of contact it is not there, but polar is there, and it is S1 is equal to 0. Only condition you have to have is the point should not be the center of the circle. Except the center of circle, anywhere you can have inside the circle. Now, when you take the point as on the circle, there is no difference between the tangent, chord of contact, and polar. So all three are same. S1 is equal to 0. When you take the point as exterior of the circle, now here, when you take the point as exterior of the circle, now you'll have a pair of tangents, but you'll not get tangent at P. You can say the tangents passes through the P, but you'll not get tangent at P. So when you take the point as exterior of circle, the tangent does not exist at P. Very, very important observation you have to make, right? And chord of contact is S1 is equal to 0, and the equation of polar is S1 is equal to 0. So if you just remember this simple table, you can easily understand the entire concept of the tangent, chord of contact, and polar of the point. So let us take one simple problem here. Find the polar of the point 1, minus 2 with respect to circle. Circle equation is given as x square plus y square minus 10x minus 10y plus 25 is equal to 0. Okay, so the problem should be simple because you got circle equation is given to you, the point is given to you. So what is the equation you're going to take? Simply S1 is equal to 0. So first of all, what is given? Equation of circle. Then what is the value of G, F, C? So 2G value is minus 10, 2F value is minus 10, and C value is 25. So 2G is minus 10 means G is minus 5, F is minus 5, C is 25. So you got the value of G, F, C. What is the point? Point is 1, minus 2. So x1 value is 1 and y1 value is minus 2. As it is, substitute these values in the equation. What is the equation of polar? S1 is equal to 0, xx1 plus yy1 plus g times x plus x1 plus f times y plus y1 plus c is equal to 0. Now, what is the value of x1, y1 here? And what is the value of gfc? Substitute these values and get me the answer of the equation of polar. I'll give 15 to 30 seconds. Children, so the x1 value is 1, y1 value is -2. So x into 1 plus y into -2, g value is -5, f value is -5, and c value is 25. Substitute these values. Now what is it you get? X into 1 is x minus 2y minus 5 minus 5y minus 5y, and minus 5 into minus 2 is plus 10 plus 25. So you can rearrange this as minus 4x minus 7y plus 30 is equal to 0. So there are two negative signs. So you can write as 4x plus 7y minus 30 is equal to 0. So the simplification part, I believe you can do it. Okay, so equation of the polar is given as 4x plus 7y minus 30 is equal to 0. Now, when you take the equation of circle as simply x square plus y square is equal to r square. So you have got the center as 0, 0, radius is r. So you can put the value of g as 0, f value as 0. So equation of the polar would be xx1 plus yy1, no g because g is 0, no f because f is 0, and c value is minus r square. Simply xx1 plus yy1 minus r square is equal to 0. So till now we have discussed about finding the polars. What exactly is polars? You are not touched what exactly is a pole. So the point from where you are getting the polar is a pole, right? So that is a focused point, the point where you are getting the polar. So from place where you are getting the polar is a pole here. So if you take the line as Lx plus My plus n is equal to 0 and circle equation as x square plus y square is equal to a square, then the polar is minus a square L by n minus a square m by n. So let us try to prove this result. You've taken the line as Lx plus My plus n is equal to 0, right? And the point you've taken as x1, y1. So you've taken the point as x1, y1, and you've taken the line as Lx plus My plus n is equal to 0. So circle equation is x square plus y square is equal to a square. So what did I do here? First of all, you find the polar of the point. What is the point? x1, y1 with respect to the circle x square plus y square is equal to a square. So what is the polar formula? Just now you have taken previously. When the point center is 0, 0 and radius is a here. So xx1 plus y1 minus a square is equal to 0. So you are actually saying that you are finding the polar of this line. And you got one more equation for the polar. So there are two equations for polars. Equation 1 and equation 3 both represents polars. So what is the meaning of it? These two equations should be proportional. So equation 1 and equation 3 represents the same straight line. So the meaning of it is the coefficient of x, the coefficient of y, x here, coefficient of y, and constant term here and constant term here should match or be proportional. So we can say x1 by L is equal to y1 by m is equal to minus a square divided by n. So when you try to take this, you get the value of x1 by L is equal to minus a square by n, and y1 by m should be equal to minus a square by n. So if at all you just cross multiply, you get the value of x1. So x1 is going to be minus a square L by n, and y1 is minus a square m divided by n. So you got the value of x1, y1. So you are calling this px1, y1 as a pole here. So you got the value of x1, y1. So the pole is minus a square L by n minus a square m by n. So remember this as a formula here. It can be asked for a 2 marks question in the examination, right? Now, if it is given for a 2 marks, then you can use a formula and write the answer. But if it is given as something like a 4 marks question, you need to follow this procedure. So the formula is going to help you only for solving in a quick way, but understanding the concept and all this, the method is going to be very, very important. Okay, so try to understand this method, how we have been done. So let us take, instead of this equation of circle, we take a general equation of circle or standard equation of circle. So you are going to take the line as Lx plus my plus n is equal to 0, circle equation as standard equation x square plus y square plus 2gx plus 2fi plus c is equal to 0. So when you take this, then the polar is given by this formula. So you have got minus g minus f here. So this is what is center of circle here. R here. R is nothing but radius of the circle, right? What is the radius? Square root of g square plus f square minus c. And you got same L, M, N. L, M, N. But you got Lg plus Mf minus N. So this point you are going to get using this method. So it is only for the theorem sake, for practice sake, or problem solving sake, we follow the general method of solving, just like the previous method what taken. So let us take the proof of this. You take the point Px1 y1 be the pole of Lx plus my plus n is equal to 0 with respect to circle given x square plus y square plus 2gx plus 2fi plus c is equal to 0. So you got line equation and circle equation. So what is center? Minus g minus f, right? So you're going to first find a parallel equation. So you say you're going to find the polar of the point. What is the point you have taken? X1, Y1. You're going to find the polar of the point. So we know that it is x1 plus y1 plus g times x plus x1 plus f times y plus y1 plus c is equal to 0. So when you have taken the previous problem here, the previous result, equation was simply xx1 plus yy1 minus r square. So you not have any problem of coefficients. But you see that here you got x here and x here also. So what is that you do is rearranges. So how is it you rearrange? Collect all the x coefficients, collect all the y coefficients, collect all the constant coefficients. So x coefficients, so it is x1 plus g of x, y1 plus f of y. Then remaining terms gx1, fy1 plus c. So you can write this entire equation like this. Writing the x coefficients, writing the y coefficients, writing the constant terms. So it is always advisable, remember this equation only, right? You can always generate this equation with the help of rearranging. Okay, so you see that equation 1 is a polar, equation 3 is also a polar. So equation 1, equation 3 represent the same straight line. So what is the meaning of it? The coefficients of x, y, and constant should be proportional. So what is the meaning of it? It means that x1 plus g by L is equal to y1 plus f by m is equal to gx1 plus fy1 plus c divided by n. Now you got an equation here, like you need to find out the values of x1 and y1. So what is that you have done earlier? When the values were given, you have taken any two here and solve the equation. Again, you have taken second pair and solve the equation. But here you observe that it is general values. So here x1 is not known, g is not known, l is not known. So that reason, instead of going by this the general method, you are going for assuming all these values as a common number called as k. So you say that x1 by g by l is k, y1 plus f by m is k, and gx1 plus fi1 plus c by n is also equal to k. So you have just taken one number called as k, where k is a unknown, which you are going to find out later. Okay, it's not required. Okay, so you need to find out the value of x1, y1 from this. So first of all, you take the first one, x1 plus g by l is equal to k. So second one, y1 plus f by m is equal to k. And third one, okay, so we just take these two first. So x1 plus g by l is equal to k and y1 plus f by m is equal to k. So you cross multiply here. So you can write x1 plus g is equal to kn and y1 plus f is equal to km. Okay. So x1 plus g is equal to kl, y1 plus f is equal to km. So just brought this l this side. So it means that the value of x1 is kl minus g and value of y1 is km minus f. So the strategy here is you got the value of x1, y1. These x1, y1s, you are going to put this in third part. This part is not taken now here. Okay, so just go for the next one here. So you got gx1 plus fi1 plus c by n is equal to k. So cross multiply gx1 plus fi1 plus c is equal to nk. But you got earlier the value of x1, y1. So what was the value of x1, y1? X1 value is kl minus g, y1 value is km minus f. So these values you substitute here. Substitute the value of x1, y1 values, we get g into kl minus g plus f into km minus f plus c is equal to nk. Now you can expand this. You got k here, and k here. So you can write k common, gl or lg. Here you got k common, right? fm or mf. And here also you got k here. So bring this other side minus n. So you got k times lg plus mf minus n. So all these three terms, this term, this term, this term are having k. So you take in common here. Then the terms which are not having k here, minus g square, minus f square, and c. So bring this to other side. So minus g square go to the side, plus g square, minus f square comes this side, it is plus f square, and plus c goes other side, minus c. So you got the value of k as g square plus f square minus c divided by lg plus mf minus n. Now, so g square plus f square minus c you can write as r square, because r you're calling it as radius. Now denominator lg plus mf minus n. So this denominator should not be equal to 0. That is a condition given in the problem. So lg plus mf minus n is not equal to 0. So the value of k you got as r square by lg plus mf minus n. So you got the value of k. So which you are supposed to find out. Now what is next? You have to find, basically you have to find out the value of x1 and y1. So what was x1? X1 was kl minus g. Y1 is km minus f. Now you can put the value of k here. K value is like this. So x1 is kl minus g and y1 is km minus f. So put the value of k there. So you get minus g. First you write minus g, then k. K value is this entire term and l value. So you can write it as lr square by lg plus mf minus m. So the value of x1 you got, and likewise y1 is equal to km minus f. So m as it is put. First you write minus f, then you can replace the value of k with the value here. You get m r square by lg plus mf minus m. So the pole of this line, the pole of the circle x square plus y square plus 2gx plus 2fi plus c is equal to 0, with of the line lx plus my plus n is equal to 0 is given by this formula. So definitely I don't recommend this method to be followed or remember this formula in solving of problems, because the problems will be given for 4 marks and you cannot, it is very, very difficult to remember the formula. So what I advise is you follow the method, how it has been solved. Use solve the problem the similar way how the method has been solved. It is going to be much easier for you, right? For simple circle equation, x square plus y square is equal to a square, the formula is going to be very easy to remember, minus a square l by n minus a square m by n. But here you cannot remember the formula. Okay, so let us take the problem here. Find the pole of the line 3x plus 4y minus 45 is equal to 0. And the circle equation is given as x square plus y square minus 6x minus 8y plus 5 is equal to 0. Right? So you got the line and you got a circle equation. So let us recapitulate how the method has been done. So first of all, what you have done, you have taken a point, a general point called as x1, y1. Then what next you have done? You have taken a equation of polar for the circle. So formula xx1 plus yy1 plus g times x plus x1 plus f times y1, y plus y1 plus c is equal to 0. Then arrange the terms, coefficients of x, coefficients of y, and constant terms. Then the resultant equation has to be similar to this equation, or this equation and the resultant equation should be always proportional. So the coefficient should be proportional. So from that you get the values of x1 and y1. So let us do like this. So let p x1 y1 be the point, be the pole of the line. Which line? 3x plus 4y minus 45 is equal to 0. Circle equation given, x square plus y square minus 6x minus 8y plus 5 is equal to 0. So from this you get the value of g, f and c. So 2g is equal to minus x, minus 6, 2f is equal to minus 8 and c is equal to 5. So g value is minus 3, f value is minus 4, c value is 5. No need of finding center here, not required, right? So equation of polar with respect to circle S is equal to 0 with respect to the point x1 y1 from the point is formula x1 plus y1 plus g times x plus x1 plus f times y plus y1 is plus c is equal to 0. So you can rearrange this x1 plus g of x, y1 plus f of y plus gx1 plus fy1 plus c is equal to 0. Now you know the value of g, f, you know the value of c. So g, f, c values as it is, you substitute here. So you substitute, so you get x1, so you get x1 minus 3 of x plus y1 minus 4 of y minus 3x1 minus 4y1 plus 5 is equal to 0. So you got equation 2 here. Now you got two equations of the polar, equation 1 and equation 2. Now you just follow the process which I mentioned earlier and try to get the value of x1, y1. I'll just wait for 15 seconds. So first of all, coefficient of x and coefficient of x should be taken as proportional. So x1 minus x1 minus 3 by 3 is equal to y1 minus 4 by 4 is equal to the constant term by the constant term. So what is the next step you do? You can take it as equal to k, like what you have done earlier, and get the value of x1, y1 in terms of k and substitute here. Okay, so what you're going to get is simply left hand side is equal to right hand side. But while solving problem here, what is it you have employed in your previous classes? How is it you have solved it? You take any of the two terms. So if at all, I take the first term and second term. So x1 minus 3 by 3 is equal to y1 minus 4 by 4. So cross multiply, 4 times x1 minus 3 is equal to 3 times y1 minus 4. So it is 4x1 minus 12. 3y1 minus 12. So here you got minus 12, here also you got minus 12. So you can cancel off 12 and 12 and get the equation as 4x1 minus 3y1 is equal to 0. This is what is the equation number 3. Now you take another pair. Either you can take the first term and the last term or second term and the last term. Right? So when you take the other pair here, yeah. So second pair you take y1 minus 4 by 4 is equal to minus 3x1 minus 4y1 plus 5 by minus 45. So cross multiplication, minus 45 into y1 minus 4 is equal to 4 times minus 3x1 minus 4y1 plus 5. Now you can expand this as minus 45y1 minus 45 into minus 4 is plus 180. Then 4 into minus 3 is minus 12 x1. 4 into minus 4 is minus 16 y1 and 4 5 is 20. So bring this minus 12 x1 and minus 12 y1, 16 y1 and plus 20 one side. So minus 12 becomes plus 12 and plus 16 minus 45 is minus 29. 180 minus 120 is 160. So equation has become 12x1 minus 29y1 plus 160 is equal to 0. So equation 3 and equation 4. So you got two equations now here, right? So how is it you solve these two equations? Cross multiplication technique. So tell me the values of x1, y1 from this. So how is it you do it? First, coefficient of y, constant term, coefficient of x, and coefficient of y. So you got 2, 3, 1, 2 order. So 2 is here, minus 3. There is no 3 here. So it means that you can take 0. Then 4 minus 3. So you get minus 3, 0, 4, minus 3. For second equation also do the same thing. You get minus 29, 160, 12 and minus 29. What is the next step you do? So cross multiplication technique. So multiply minus 3 and 160, multiply minus 29 and 0 with a negative sign, multiply 0 and 12, multiply 160 and 4 with negative sign, then multiply 4 and minus 29, multiply 12 and minus 3 with a negative sign. So you get x1 divided by minus 3 into 160 minus 29 into 0 is equal to y1 divided by 0 into 12 minus 160 into 4 is equal to 1 divided by 4 into minus 29 minus 12 into minus 3. So minus 3 into 160 is minus 480, minus 29 into 0 is 0. So you get x1 by minus 480. Then y1, 0 into 12 is 0. 160 into 4, 16, 4, 64. So minus 640. Then 4 into minus 29, 116 minus 116 plus 36. So x1 by minus 480 is equal to y1 by minus 640 is equal to 1 divided by minus 80. So when you take the value of x1, the value of x1 is minus 480 by minus 80. Minus 480 by minus 80. Y1 is minus 640 by minus 80. So you can cancel negatives here. So it is 6 times and this is what is 8 times. So the pole is 6, 8. So have you understood the procedure here? Right? So I advise you to follow the procedure instead of solving the problem using the formula. For finding the pole when the standard equation of circle is given. When you got a simple equation of circle x square plus y square is equal to a square, it is your wish. You can go by formula method, you can go by direct solving method. So formula method is going to be easier for simple equation of circle. But here I advise you to go by the method, right? So what is it you have learned today here? Very, very important concepts you learned today. So what exactly is polar and what is a pole? So polar is the points of intersections of tangents drawn from a point. And we have taken the equation of polar, S1 is equal to 0. Then if you take the circle equation as x square plus y square is equal to r square, the equation of polar is xx1 plus y1 minus r square. Then the pole for the line lx plus my plus n is equal to 0 is minus a square l by n minus a square m by n, right? So I have not given the last formula as a formula in the list, key takeaways. So the reason is the problem can be done by a general method as compared to the formula method. Okay, so if you understood today's class, I advise you to solve these practice problems and post these problems in the chat, the answers in the chat box, right? So if you post the answers in the chat box, I'll be very happy. Okay, even if you are not able to do it, at least after 2 or 3 days, you see the answers in the test. So the first question, find the equation of polar of the point 2, 3 with respect to circle. So formula you're going to use is S1 is equal to 0. Find the polar of ax plus by plus c is equal to 0 with respect to circle. X square plus y square is equal to minus r square. Now you observe the difference here. In place of lx plus my plus n, you have taken ax plus by plus c is equal to 0. But you derive the formula, right? So you need to derive the formula like this. So in place of a, you'll be having r. In place of L, you'll be having a. In place of n, you'll be having c. So the answer should be minus r square a divided by c. Likewise, the y value. Then find the pole of x minus 2y plus 22 is equal to 0 with respect to circle. The last problem we discussed, same way. Now here, if ax plus by plus c is equal to 0 is a pole of 1, 1 with respect to circle, then and the highest common factor of a, b, c is equal to 1, then find the value of a square plus b square plus c square. So how is it you do this problem is here? You find the equation of polar for the circle from 1, 1. So x1, y1 value is going to be 1, 1. G value, f value, c value is known to you, right? So we get the equation of polar. Now I said that this is also a polar. So there are two polars. So this polar and that polar should be equal. So compare the coefficients. You get x1 by a is equal to y1 by b is equal to constant by constant. Now condition given, HCF of ABC is equal to 1. So what is the meaning of it? It means that the three terms have only 1 as a common factor. So you can say that the coefficients should be equal to 1. So earlier you've taken coefficients as equal to k. So the value of k should be equal to 1. So revisit the result which you have discussed. So there you have taken as equal to k. Instead of k, you take it as 1. Why 1? Because it is given that HCF is equal to 1. So from that, you get the value of a, you get the value of b, and you get the value of c. Then after getting the values of a, b, c, find the value of a square plus b square plus c square. So this is an interesting problem here. Try to solve this problem, and let me see how many of you can put the answer in the chat box. So with this, I'll be glad to actually take up any of the questions asked, right? So what is the secret behind getting ahead is you have to start. If you start, you get ahead. Madam.
Thank you, Sanjeev sir. And the students have not expressed any doubts. There are few students who are solving the previous practice session questions, and they were asking whether the answers they're posting is correct or not.
And actually, so, I promise that I'm going to post it today.
After the session, you please go through that and then inform them whether the answers they got are correct or not. Thank you for a wonderful session. Children, we will have some more sessions in circles. To complete the circles part, it will take another 4 or 5 lessons. You keep revisiting the YouTube channel for the lessons, and then also revise the previous concepts, which will help you in understanding the coming lessons better. Thank you all. Thank you so much.